Pleasant good morning to everyone. And I want to congratulate the Philippine Society of Biochemistry and Molecular Biology for organizing your convention in spite of the pandemic. I remember I spoke in one of your session in during my younger years. I think that's in Dumaguete City. So now this is my second time talking to you after maybe decades. So I'm excited and I'm thanking the society for giving me an opportunity to relate to you some of the practical aspects of if you talk about genomics, if you talk about biotechnology, if you talk about biochemistry in the agricultural context. I want to share my slides now. So I crafted the title Reshaping Agricultural Research and Development in Time of Pandemic, and particularly on integrating the product of biochemistry and molecular biology, which is biotechnology, to agricultural value chain. In my next slide, sorry. So I just want to show you where most of you or some of you don't know yet what is CIRCA. I'm now leading CIRCA. CIRCA is the first regional center, or this is Southeast Asia Regional Center for Graduate Study and Research in Agriculture. It is established by the Southeast Asian Minister of Education Organization, we call it SIMIO, to build capacities in agriculture and rural development in Southeast Asia. We just launched our 11th five-year plan. So you could estimate we are more than 50 years now. This is our 11th five-year plan, and we have an overarching theme on accelerating transformation through agricultural innovation, where biochemistry and molecular biology is very big part of it. We just launched it 2 months ago, and this will be for 5 years. So we already have our mission on this one is we want to be a leading enabler and champion of excellence in agriculture and rural development in Southeast Asia. And we have a vision to elevate the quality of life of our agricultural families through sustainable livelihood and access to modern networks and innovative markets, which I'll be mentioning a little bit later. So this is the core programs of CIRCA in our new five-year plan. So of course, the main core programs is we have research and thought leadership. We're doing our research, including the policy research and developing the future leaders, especially for higher education institutions in the Philippines and Southeast Asia. And of course, we have our education and collective learning, where we offer our different types of scholarship and to strengthen the different universities in Southeast Asia. And we have a new department, which is Emerging Innovation for Growth. This is in response to the emerging disruptions, emerging Industry 4.0, or we call it Agro 4.0, digital agriculture, new thinking, design thinking, co-sharing, and all those, how to start business in agriculture and how to engage our youth in agriculture. So this is where the crazy ideas will come in. So if you have crazy ideas and you think this will be of help for our future farmers or for our farmers to make them more productive, to make them more agripreneurs, so this is where we could work together. This is the Emerging Innovation for Growth, where we do some of our agri incubation and technology transfer. So as I mentioned, we have recently launched our 11th five-year plan for CIRCA. Sorry, it's moving very fast. And we saw the need to rethink how we approach things, particularly in terms of how we view agriculture, how we view food, and how we view food production. Clearly, there is a need for an accelerated transformation of the agriculture sector so that it can be fully maximized for human well-being. Essentially, Shirka, at Shirka, we are asking the question if an accelerated transformation through agricultural innovation is necessary. We strongly believe that the systematic and integrated innovation here would require a new mindset where farming is viewed as a sustainable business. This is in contrast of the traditional view that farming is merely about production, production, production. Hence, we want to emphasize about ecosystem thinking, circular value chain, future-proof products and services, low ecological footprint, agriculture 4.0, and the need for the next agriculture and rural development transformative leaders for the Philippines and Southeast Asia. I just want to show that to make this really happen, we need to have a transformation, innovation for transformational change. So we have to do a lot of innovations, from conceptual innovation, how we think, how we include the youth and the women, institutional innovation, how we will be participatory, how we influence the governance of the institution, social inclusion, social innovation, of course, the technological innovation where your society, our society will come in, especially in agriculture and biotechnology, and of course, policy innovation where we have to influence our policymakers, we have to influence how we will implement most of our innovation. I just want to run a little bit on Circa's 7 priority areas where I know that your society or your institutions or your university wants to come in. We are prioritizing our agribusiness models for increased productivity and income. So we're emphasizing business here, sustainable farming systems and natural resource management, food and nutrition security, where biochemistry and molecular biology has a very big role here. Transformational leader and for agriculture and rural development, of course, gender and youth engagement in agriculture and rural development, enhance agricultural and rural development towards resilient climate change, climate resilience, and of course, this one, which is very important in our present pandemic, eco-health, One Health applications to agriculture and rural development, where we want really all aspects of health should be looked at the same in a holistic way, from the animal health, plant health, environment health, and including, of course, the health of our society, especially our agricultural farmers. To have a desirable commercial varieties of product, I'm talking about agricultural crops. You need a good team to make this happen. Good breeder, good geneticist in the team. Of course, this includes plant pathologists, statisticians, engineers, to have a team of scientists to craft the products. And it should be interdisciplinary. You must have elite and diverse germplasm to play with. And of course, this is where the biotechnology will come in, good tools and resources to make all these three ingredients should be there to have a desirable commercial varieties or products. And if you want to relate it really to the real, to make things, to develop varieties, to develop good products, you have to look at the genetic gain. It's genetic gain, genetic gain, genetic gain. That's what you have to emphasize. Genetic gain over time. So genetic gain is the amount of new value addition you could get in a period of time as fast as you can. So this is the genetic gain, which is RT, and this is a function of selection intensity. If you select too much, selection is very high, you may not select anything. If your selection is very low, you cannot produce also a quality, a better product. So it's a seesaw, and you have to be very discerning on this one. Selection accuracy, this is where biotechnology tools are there, which I'll be mentioning later. Genetic variants, you need a lead germplasm to play with, and you have to have years per cycle. So you have all these double haploid, tissue culture, you have to use marker-aided selection, genomic selection, or CRISPR-Cas to shorten the gap of producing your product. So keep this in mind as we move forward. Maybe I'll just give you an example. When I was with the International Rice Research Institute, the team has been working on C4 rice. This is a very classic example of how we could increase the rice yield by 50%, double the water use efficiency, improve nitrogen use efficiency, and of course the C4 photosynthesis rice is C3, and we have to convert it to C4 because C4 photosynthesis is one of the few evolutionary mechanisms that could deliver the superior combinations of benefits. So C3 rice, they want it to make it C4. This is funded by the Gates Foundation, and this is a long shot. This is you need really a rocket science here, because it takes a lot of energy to change from an anatomy change. You have to make the biochemical change. You have to do the fine tuning to make it C4. So we are making rice behave like corn. We are making rice behave like corn. That's the C4 re-engineering photosynthesis for developing an efficient rice variety. So what they are doing now is really doing some genetic knockout. They are studying the C4. They are doing some mutation to knock out the C4-ness of that species to make it C3. Once they see it, they got what are the genes responsible being knocked out to make the C4, C3. That's where they start studying how to make rice, incorporate those being knocked out, put it in rice, make it function, and make it a C4 rice. So it's still a long journey. That's why I call this the mega rice. May gagawin pa. So mega rice, may gagawin pa to make this happen. And the other one, which is very near my heart also, is the nutrient-rich rice varieties that they develop. So you can see the provitamin A in rich rice, golden rice, which is biotechnology has done a great role here. Now it's almost in the commercial scale. Zinc rice, from 16 ppm, they were able to put it double or maybe triple using ordinary breeding, at the same time GMO. And the iron-rich rice, they could double from the level of 2 ppm, they could go up to 12 to 15 ppm now, and more than 50 ppm of zinc using biotechnology. So that's the example. So what are the learnings from agri-biotechnology? So I just want to share to you for my own thinking that modern biotechnology is changing very fast. Agri-biotechnology is a very powerful tool, a powerful driver for well-directed change to meet human needs. But agri-biotechnology are also powerful tools and a laser gadget to keep food production in step with the modern demands, including, I called modern demands includes the new luxury of people, new nutritious food, more fiber, more healthful foods for the consumers. Fast tracking the agricultural product delivery for human needs and luxury. But we have to be warned ourselves that biotechnology tools is like politicians sometimes during campaign period. It makes many promises. So sometimes because of these movies or articles, we promise too much. We have to show that there's a lot of research before anything will happen. A lot of funding, a lot of skilled people to make this happen. Therefore, we have to be responsible and realistic in showing the potential of this technology. So, as I promised, I want just to give you a glimpse of how to integrate biotechnology in the agricultural value chain, especially in research. These are the stages in modern crop breeding. So these are the 4 stages that you have to look. Don't look at only at the level 3. You have to look, sorry, or you don't just look to item number 3, which is the breeding or the research proper, but you have to look at, you have to review first the existing crop breeding program of your institute or your company or your university. Develop a crop master plan to include different breeding strategies. You have to include the market people, market intelligence. You have to know what will be your immediate products, intermediate products, and future products. You must make it market-driven products, or else if it's not market-driven, it will not flow to the market, it will not flow for the farmers, it will not be accepted by the consumers. It should be market-driven, product-oriented. You have, in any research to make it happen, to make it sustainable, it should be product-oriented. You must produce a product that could be commercialized. And you have to prioritize these strategies, establish the integrated breeding platforms towards breeding genetic gain, speeding genetic gain, and of course, encouragement. You have to engage the team to make this happen, and you need effective communication. This effective communication to ensure the implementation of your breeding program or your crop breeding program. So this is where's your strength, and of course, after that, you develop the crop master plan. This is very important. You have to look at the future. So you have to look at what are the strength and weakness and opportunities and threats. And you have to analyze the different market segments, crop breeding strategy, focus on market segments that you are very strong. Don't go to the segment that you have no comparative advantage, and you have to develop your product profile. I'll just give you another product profile, which when I was at Erie, this was the product profile we are looking. So you must have a must trait. These are the win traits. You must have higher yield than existing varieties. You have these different drought tolerance. If you must have also the product development strategy, you must have an immediate product, eating quality. You must have an intermediate product, which are the expansion driven. In the next 5 years, this will be your immediate product, intermediate products, and the future products like low carbon footprint varieties and multicolor varieties. For example, this is corn. This is the corn I usually work before. So you have to look at the different. Maybe you are looking for 3-ear corn or 2-ear corn, depending on the size of the consumers, what the consumers need. And we are finished there. So we have to look at also on the 3rd stage, which is the establishment and integrated breeding platforms towards speeding genetic gain. So you must have a crop breeding team. You have to look at automation and mechanization to make it very fast in your phenotyping. Stage gate approach in how you use the technology, which I'll be mentioning one later. You have to use rapid generation advanced facilities. You have single seed descent, double haploid to make our breeding cycle very fast. And of course, this is a genomic selection strategy. I hope some of you are already familiar with this technology, which many of the breeding programs are doing it. We have to optimize the genomic selection procedure and implementation of genomic selection through research management approach. And you have the gene editing or CRISPR-Cas, which is the very in thing now. And of course, very important is collaboration and public sector, public-private partnership program. I want to have a run through to you. This is an example of research gate approach, stage gate approach, where how you will evaluate your markers or your genes if they are really unique. If they are not unique, then throw them away. Go back to the new evaluation of new donor until the QTL evaluation, refinement of your QTL, candidate gene validation, diagnostic markers, up to application of your marker or QTL. So genomic selection again is this is where you have a training population, you have the genomic population, and you use the genomic estimate breeding values to estimate the next selections you will do. This is another long lecture, but the main thing here, it will make fast your selection, more accurate, and you will spending less money in your selection process. And with this, it's a challenge to incorporate the CRISPR-Cas targeted recombination, and you combine genomic selection and gene editing to make this a potential to double the rates of yield gains. And this is an example, a classic example, comparing the conventional breeding and breeding with genomic selection. So as I mentioned, this will just be, this will reduce, it will be more accurate in selecting by using phenotyping, genotyping only, instead of phenotyping everything. At the same time, it will reduce your number of materials that you will be testing because you already have pre-screening using the genotyping approach. And again, implementation of the crop breeding, engagement of crop breeding team, and effective communication to ensure sustainable implementation. So you have to communicate to your team to make this, or else you'll go back to the traditional breeding that you're doing. Again, this is the summary, and the summary of the implementation of the breeding program, from evaluation of the existing crop breeding program, developing the crop master plan and breeding strategy, establishment of integrated breeding platforms, this is the new one, and establishment of a team and effective communication to ensure sustainable implementation. And with this, I may share that with this COVID-19 pandemic has underscored the connection between the supply chain and consumption pattern, and the urgent need to redefine agriculture system as the food system. So I just want to challenge that the role of higher education institution to produce agricultural graduates with transformative mindset, including the biochemists and the molecular biologists, who are adept in understanding the growing complex social concern and were able to affect positive change now and in the future. And this COVID-19 wants us to reflect on the following questions. What are the major priority areas for research in agriculture and applied fields to accelerate transformation towards sustainable agriculture and food system? And how can the human capital of the higher institutions, research institutions, particularly through the research academics initiative, to strategically welded to fully maximize to solving the present social concern, particularly the pandemic. And the research funding will be limited. We have to be very conscious of that. What innovative solution will be put forward for your institutes to continue to enhance your capability in knowledge generation? And actually, we want to propose these key priority areas for research and development across disciplines. You have, as I mentioned, we have to be more multidisciplinary. We have to look at the 4 dimensions as we do our research, from the food security pillars, which are availability, accessibility, stability of food, and utilization of our food, going to the agricultural value chain, which is the producers, farmers, producers, processors, manufacturers, distributors, retailers, and consumers. So you have to look at those different angles up to the level of analysis of your research, from biosphere to ecosystem landscape-based population communities, up to the gene or cell or organism level, and the different modalities that we want, what approaches, methods of approach we want to do. So I just want to emphasize to maximize the human capital of higher education institution and research and extension university. must now strengthen multi and interdisciplinary studies, and we must have to look at the larger societal problem. More researchers are needed who are good in doing basic research, basic science, but also good in navigating the development dimension of their work to shorten the gap between research productivity and its translation to economic development. And I just want to show you also the major priorities in reshaping agriculture and rural development. And in higher education in time pandemic, we have to enable environment to engage mutual learning and co-learning, and you have to be interdisciplinary. You have to knock down all these walls in our laboratories to have to work together and incentivize scientific productivity that value beyond mere publication, but also the different piece, which is people, partnership, patents, products, processes, and profits. And we have also to retool the in-application for intellectual property rights, patents, technology transfer system, technology-based incubation and entrepreneurship, more grants and extension awards, and enable faculty and students to engage with industry, community beneficiaries, and other stakeholders across the agricultural value chain. And you have to re-articulate our COVID-19 response for our ongoing projects. I may call it, we have to COVIDize our projects now to make it fundable, create crafting of new research proposals, and relate it always to COVID-19 and the future pandemic. And these are the major, we have to strengthen collaboration, and we have to reshape our implementation of our research priorities by design thinking approach. We have to resource sharing of our human and financial capitals to strengthen linkage between basic and applied research with the industry needs, redesigning and implementing digital agriculture infrastructure, open innovation system across agricultural value chain. And to support publications also, we have to support publications and including crop varieties publications and of research products, not only the process, but also livestock breed, encourage supporting innovative throughout the research process from conceptualization, implementation, and data generation up to aiming to contribute to the public goods. So in all, I just want to emphasize that the academic industry government interconnectivity model on research collaboration and co-sharing of financial resources, we need this one to shorten the gap between research and knowledge utilization. And this is my last slide. Universities are the key players in society's overall ability to achieve and aspire food security and economic development, but they also must aspire more to contribute beyond towards economic development that is sustainable, inclusive, environmentally friendly, and most importantly, resilient to current and future pandemics and other unanticipated disruptions. I just want to show you, this is in 2015 when Bill Gates visited Erie, and we have a project with him, and we use some modern technology, biotechnology to develop stress-tolerant rice varieties for Africa and Southeast Asia. And I was able to talk to him, and you could see here I'm asking here for more fund, and you could see here his hand now going into his pocket. I'm assuming he is getting money to fund our research. And again, as I mentioned, the reality of genomics in agriculture is won or lost at the farmer and consumer level, where applicability and sustainability is tested. Thank you very much, and good morning to everyone.